All right, let's get started. For most of the problems on the test, Kiara, I will give you a diagram because doesn't the diagram make it easier? Yes. But you still gotta know, like a lot of the problems involve similar triangles. You gotta know when to use it. Like for the related rates problems, I believe 3 problems involve similar triangles.
The shadow.
Oh, what am I doing? Alright. Okay, what was written here?
31 to 42.
No way!
And QQ.
Once you missed one. Q4.
Chase!
Just number 4.
It's 2, 3, 4. I don't know what you're saying.
Just let him do it, you're gonna learn.
Okay, there's no way we're gonna do all this. There's no way. Some people came in for help this morning.
Well, I'll be quiet. Let's get through this.
Thank you, Yoshi.
I did the first like
Okay, we are on section 5. So you guys are, by now you guys are experts in optimization though, right?
Not really.
That's 5.4. Now we're doing 5.6, the second half. After the first half, you should be pretty proficient, and after you do the second half, you guys should be experts. So the first problem I see up there is number 30.
Yeah.
Okay, you guys picked one of the toughest problems. I'll give you a hint. I gave this to them last year. In fact, I gave them AB. But AB, they're not as, what's the word I'm thinking of?
Prowess.
Even though we did it on the board, okay,
Thank you for this
the
dubious.
pole is 50 feet high. That does not change. Now, remember on problem 29, you had a man that's 6 feet tall?
Height.
But see, now it's not constant, like the height of the man is constant, right? But now you drop the ball, and so this distance between the ball and the ground is changing, so label it with the variable. Now, probably what's going to happen is I'm going to label the picture for you. Probably.
Thank you.
That's what everybody uses the same variables, plus it also helps you out, right? Now, when the light shines on the ball, then there's a shadow over here, right? So we're trying to find how fast the shadow is moving. So what do you want to call this? Shall we call it X? You can call it whatever variable you want. Now, what about the distance between the pole and the point where the ball is dropping? Is that distance changing or is it constant? It's constant at 30 feet, right? So this is the picture I'm going to give you if I give you this problem. So the first step is to write an equation. Now look at this picture. Do you see similar triangles? Yes, the baby bear is in the womb of the mama bear.
Where's the Papa Bear?
She's out of the picture.
Typical family.
So, short leg over long leg equals short leg over long leg. Or whatever you guys are going to do. Did everybody get that at least? Because if you don't get this, there's no choice. I have to give you, that's a fatal error. Minus 12.
Oh. 88 is a prominent score.
There's nothing you can do that's going to gain points, that's why. Now, do you want to take the derivative here or do you want to simplify? I rather simplify it. So cross multiply 30y plus xy is equal to 50x. Second step. What is the second step? Remember, it's a 3-step process.
Take out the y.
Take the derivative with respect to time. So just go across the board. What's the derivative of this? 30 y dot. Are you guys using y dot or dy dt?
dy dt.
I don't care what you use. It doesn't matter. Here I see a product. You got to use the product rule. Derivative of the first, leave the second one alone. Leave the first one alone. Derivative of the second. If you don't use the product rule, that could be a minus 12. In fact, not might. It will be. Equals 50 times x dot. Okay, you do that, you get more points. And then what's the third and final step? Plug in the numbers. Okay, now the question is asking how fast is the ball's shadow moving along the ground half a second later? So we want to compute x dot, dx dt. So in order to compute x dot, I would have to plug in numbers for x, y, and y dot. Okay, let's do that. Now, sometimes they actually give you the information. Sometimes you gotta figure out that information. So I guess what makes this problem harder is you gotta figure out the information. So, what did they tell you there? The distance that a ball drops is 16, S equals 16t squared. So half a second after you dropped it, see you start here, you dropped it. Half a second later, what was the distance it dropped?
4.
Plug in 1/2 there and you get 4. So therefore, at that moment in time, what is y equal to?
46.
46. Everybody see that? Okay, now, if y is 46, is there a way I can figure out what x is? Yeah, you use this equation that you wrote. That's the equation that relates the variable. So, if I plug in 46 for y, okay, let's do it. 30 times 46 plus x times 46 is equal to 50x. So 30 times 46 is equal to 4x. X is equal to 30 divided by 46 all over 4, which is 2 times 2. Can you see why you did that? Because you're not going to have a calculator in this test. Because some of you are just plugging in on the calculator. I laugh at that. 2 goes into 30 15 times. 2 goes into 46 23 times. What's 15 times 23?
It's 270.
345?
Yeah.
Wait, what?
You go 15 times 20 and then.
Yeah, just think of 23 as 20 plus 3. And then distribute the 15. 300.
Just use FOIL.
Yeah. How come Hirano knows that? You went to 5th grade.
Oh, that's why.
Oh, that's messed up.
5th grade, distributive property, right?
Is it not FOIL?
Really?
45.
I did that yesterday.
Okay, now here's the hard part of the problem. What is y dot? How fast is this distance changing? Well, isn't that pretty much asking what is the velocity of the ball then? So if this is the position equation for the ball, how do you get velocity?
Oh,
You take the derivative, which is 32t. So half a second after the ball is released, what is the velocity of the ball? If you plug in a half? 16. So therefore, what is y dot? No, it's negative 16. Now, for those of you who put a positive 16 there, that's at least a minus 2, at least. No, because the sign is important. If the derivative is positive, that means the quantity is increasing. If the derivative is negative, the quantity is decreasing. It's very important, that sign. So that's why you gotta look at the picture. Is y getting bigger or getting smaller? Smaller. Smaller, therefore y dot has to be negative. Now, all you have to do now is take these numbers and plug it in. You want me to do that? Okay, I will. 30 times negative 16 plus x dot times 46, okay, plus 345 times y dot negative 16 is equal to 50 x dot.
Oh, no calculator.
No calculator. So, look, no, it's
Mental
easy.
method.
No, look how easy this is. If I move this on this side, don't you get 4x dot? And then look at these two. What can I do with that? Can't I factor out a negative 16? Let's just factor out a negative 16 to start with. What's going to be left? 30 plus 345. But 4 goes into 16 4 times. So it's just going to be negative 4 times 375, which equals negative. What's 375 times 2? 750 times another 2, 1500. Negative 1500. Okay, now, you got to answer the question. How fast is the ball shadow moving along the ground? Now, x dot is negative 1500. What is this? What are the units? Feet per second? But you got to answer the question. The question is, how fast is the ball moving along the ground? The answer is 1500 feet per second. How come? See, there's a difference between compute dx dt, which is negative 1500 feet per second, but the question is asking, how fast is it moving along the ground? The answer is 1500 feet per second. You see the difference?
y.
Wait, does everything need to be answered in a sentence?
No. Don't worry, on my test, I'm just gonna ask you to compute the x
No, but is
dt.
homework,
Why?
like homework, should we just put the answer? Or-
Am I really gonna even look at your homework? To be
Yes.
truthful?
Perhaps.
Oh.
Maybe I'll look at one
You
problem.
took
Yeah,
minus
you get
6
4
off
and
my
then
last
where do you where'd you get the
That's
And you
because
put
I
that
had
Y.
time to look at it.
Oh, wait, never mind.
Minus-
Wait. I didn't take off 6. You got minus 6.
No.
There's some part.
Yeah.
Because he checks out.
How do you get
random
y equals 46?
Were you here 5 minutes ago?
S equals 16.
Using this.
Yeah, you get 4 and then
So if this is 4 and the total
4.
length is 50,
Oh, you said-
wouldn't that
oh,
be
yeah.
46?
that makes
Wait,
sense.
do you have pieces on?
You either gotta put x dot or y dot or dy dt.
We're so mean.
No, do not write y prime, because if you do that, take off 5 for each prime. No, when you're taking the derivative with respect to time, you cannot put prime.
Yeah.
What if
You
I
gotta
let
put dot.
What if
Didn't we talk about this the first day?
just put a legend?
Newton's dot notation? I'm pretty sure I
Just
did.
put y prime equals y dot.
How about partial
Or just
derivative?
go negative 20
You
is
can
done.
put that.
Just put y prime equals anything.
I finally got the came through Amazon. I got a chocolate. Okay, next question is number 31. No, you see, you guys are asking the wrong questions. These are so easy. The picture is given. That's okay. That's okay. We'll do the wrong problems.
I asked 31 to 42.
Okay, I am only gonna do 31A. You guys are gonna do 31B.
There's only.
No, there's a part B. Right?
That's what it is.
See, they're asking 2 questions. I'm only gonna answer the first question. Okay, look. Here's theta.
No, you didn't.
This is 132 feet, and then what is this? This distance is changing and call it x. Now look at this picture. First step, write an equation that relates to variables. Theta equal tan inverse x over 132, correct? Or would you rather go tan theta equal x over 132? It doesn't matter, it's gonna come out to the same thing no matter what. But you know why it's better like this? Because well, whatever, let's just do it. Theta dot is equal to 1 over 1 plus x over 132 quantity squared times the derivative of box, which is x dot over 132, correct?
That's complicated.
Tan inverse box, 1 over 1 plus box squared
Oh,
times
gosh.
the derivative of box. Okay, and then what's the third step? Plug in numbers. Now let's read the problem. The car is moving at 264 feet per second, so what is
X
so,
dot.
so what do I plug in for x dot?
160.
No, okay, here, let me read it.
Which way is it?
The car is moving at 180 miles per hour, which is 264 feet per second. So what is x dot?
260.
No, minus 2.
Negative.
Negative 264. How come negative? Because if the car is moving that way, isn't x getting smaller?
Yeah.
So the derivative must be negative. So it's negative. That minus sign is going to cost you. Just for that, I'm going to make it 4 points. And then what do I plug in for x? About how fast will your camera angle be changing when the car is right in front of you? So when the car is right in front of you, right there, what is the value of x?
0.
0. So if I plug these in, you get theta dot is equal to 1 over 1 plus 0, which is 1, times negative 264 over 132, which is negative 2. And how do I measure angles?
Radians.
Radians per,
Second.
is it seconds? Yep, it is. So that means this angle is getting smaller at the rate of 2 radians per second. Doesn't that make sense? It's negative.
Wait, why did they always put,
What?
why did they spell out set?
Yeah.
Like, can you put S?
Yeah, everything's optional in this stuff.
No.
Is S conventional for seconds in physics?
Yeah.
It is, right?
Why is it inaccurate?
How is I don't know, it's not.
No, like meters per second is M over S.
Okay, yes, you can use S per second.
Oh, right. Wait. It's just asking how fast the camera is changing, so isn't it 2 radians per second, not negative?
No, but isn't it dropping?
How fast will your camera angle be changing? No, they're asking how fast is it changing. So the answer is -2 radians per second. Okay, but what if they ask, how fast is the angle decreasing?
Then just two.
Then the answer would be just 2 radians per second.
That's true.
But I'm not going to try and trick you. And on the AP exam, they're not going to try and trick you.
Are you
Okay?
sure?
Yes.
They're
they're-
not sure.
How come on this?
On my
one-
test and on the AP exam, usually they'll ask you how fast is the angle changing. The answer is -2 radians per second
Okay.
because it's getting smaller. You get it? Okay, and then for part B, it says half a second later. So what does the picture look like? Okay, this is when the car is right in front of you. Half a second later, then the picture looks like this then, right?
Yeah.
You guys can do it, right? So now the picture just looks like this now. Is that gonna be a problem?
Yeah.
It's the same equation, it's the same derivative. What's the only difference then?
It's not negative.
What is x dot then gonna be? Yeah, so x dot will just be positive 264. Because the car is moving that way, so x is getting bigger. And then half a second later, what is the value of x?
1/2 times 1.
Okay, here, let's write this up. X dot is equal to positive 264. What is the value of x half a second later after here? Well, if the car is traveling 264,
132.
what is it? Feet per second? Then a half a second later, wouldn't it be 132? Yeah, so come on. I think you guys can plug that.
Child's play.
See, you guys are picking the wrong problems. We are not doing 31 to 42. I'm scratching that out right now.
No.
We don't have time. If you have that many questions, I told you, you guys gotta come in for help.
Okay, can you just do not the multiple choice, just all of it?
Just do evens then.
Okay, you know what that is telling me?
What?
Mr. Parker didn't even do my homework yet.
You would be correct.
I know I'm correct. It used to be, in the old days, students would catch up on the weekends. But you know what it is now? Students fall farther behind on the weekends. That's what it is now. Okay, so do you really want me to do 32? Because it's really quite easy, you know. Okay, I'll do it. We run out of time, if we don't get to the tougher problems like the ones we're gonna see on the test, then we just don't get there. Yeah, we just don't get there.
Oh man. 34.
So really, this problem is super easy. You know? Okay, here's 3. The plane is going that way, this distance is changing, that distance is changing. What equation can I write just to get that picture?
X squared.
Pythagorean Theorem. S squared is equal to x squared plus 9. Second step, take the derivative with respect to time. 2s s dot equals 2x x dot plus 0. The 2's cancel out. Now, what are we trying to find? Find the car's speed along the highway. So we need to find x dot. So in order to find x dot, here, let's do it like this thing. All you gotta do is plug in numbers for each of these things. Now let's sift through the reading over here. Shh, I'm concentrating.
It's supposed to be a 5.
No, it's an S.
No, it's
That
an
distance is changing. Any quantity that changes, you have to label with a variable. Because is this distance always 5? No, you have to label it with a variable. Okay, does everybody understand that? Anything that changes needs to be labeled with a variable. But you don't have to worry, because I'm going to label it in my picture. So you guys don't, unless, maybe, I don't know, maybe I won't give you the picture.
He already made the test. He's doing this.
Okay, at the instant, the line of sight distance from the plane to car is 5 miles. So what is 5? S is 5. And then at the moment when S is 5, what is X? 4. 4, because that's a 3-4-5 triangle, right? At that particular moment, what is S dot? Well, it says the line of sight distance is decreasing at the rate of 160 miles per hour. Negative 160. Okay, so what is x dot equal to? X dot is equal to 4 goes into 160 40 times, that's negative 200. Now you gotta answer the question. So does it, this distance is getting smaller at the rate of 200 miles per second. The plane is going that way at 120 miles per hour. Gosh, this darn thing. 120 miles per hour. Therefore, how fast is the car moving that way? If the distance is closing at the rate of 200 miles per hour.
80.
Thank you. 80 miles per hour. Okay, you guys in physics learned about relative velocity, right?
Sure.
Yeah.
So if this is going this way at 120 miles per hour and that's going that way at 80 miles per hour, that's the same thing as this distance closing at the rate of 200 miles per hour, right?
Oh.
Doesn't that just make sense?
Yeah.
Okay, there you go.
Conceptual.
All right, next problem. I'm erasing it.
No, you erase QQ.
Okay, well, I can't remember what I wrote there. Wasn't it just everything?
Yeah.
People, we really don't have time. You guys better win.
Wait, can you just do the hard problems?
34.
30.
Okay, I see 33 other. That's kind of an important problem.
Okay, let's do that one.
You could just be full.
Okay, now they give you a picture. But their picture is junk. You know why their picture? Because the building is 80 feet high.
Something visible.
The sun is shining down. This angle is changing. See, the book labeled this with 60 feet, but as the sun moves, doesn't the length of the shadow change? So that should be labeled X or Y or some variable. That they shouldn't put 60 there. It's misleading. Okay, look at this picture. What relates the variable? What equation can I write? Theta equals, shall we go with our normal tan inverse 80 over x? Okay, take the derivative with respect to time. Theta dot is equal to 1 over 1 plus box squared times the derivative of box. Okay, let me ask the question. What is the derivative of box, Hirano? Read it off your paper.
80 over x dot. Or is it?
Please.
What?
No.
Oh.
No. Wait, that's
Dot
wait.
over.
Okay, I'll give you a hint. This is the same thing as 80 x to the negative 1 power.
Negative 80
Okay, negative 80
x dot.
okay, x dot.
Oh,
Box to the negative 1.
x to the negative.
I hear whispering. Very good, Hirano. Got it. Okay, but Hirano, if you did what you did, what did you say? 80 over x dot.
Yeah.
See, because that's neat. That's not even a quotient rule. That's like
That's
a
a
made-up
fatal.
rule from
That's a
another
fatal.
world.
That's definitely.
That would have to be a fatal error. That's a minus 12 right there.
Hey, 80 is a
I'm
starting
sorry.
score.
At least use the quotient rule then, right? Low,
Still good
but do
ones.
not make up, I don't know what that was. That was just something you made up.
You're wrong.
Okay, what are we trying to find in this problem? At what rate is the shadow's length decreasing? So they want us to compute x dot. So in order to compute x dot, we gotta plug in numbers for it. We need theta dot, we need x, and that's it, yeah? Okay, so here we go. What do I plug in for x?
60.
Very good, 60. At the moment when x is 60, what do I plug in for theta dot? Well, let me read the sentence and some of you don't have your books here. At the moment in question, the angle the sun makes with the ground is increasing at the rate of 0.27 degrees per minute.
Well, gotta change it.
So do I just put 0.27 here? No, because when you work with angles, it has to be radians. So we need to convert that to radians per minute. So let's do some dimensional analysis.
Yeah.
Degrees, radians, pi radians is 180 degrees. And you know what? I would change that to 27 or over 100 because you're not going to get a calculator on this test. So what can I do here? Any canceling? 9 goes into that 3 times, 9 goes into the 20. So that would be 3 pi over 2,000. Okay, so these numbers you plug in and then you compute x dot. Okay, you're going to get an answer. And what are the units going to be? Because I always check this problem for AB, so probably BC I will. If I'm going to check one problem, this might be it right here. Okay, so what are the units? Come on, somebody tell me. Feet per minute. No, minute. Look right there. Okay, I'm going to tell you right now, the related rates problem. units is worth 2 points now. So like if you accidentally put feet per second, I'm sorry, -2. 98 is a darn good score.
So if we just put the units, then we can get that.
No, it doesn't work like that on the AP exam. So some students, they don't know how to do anything, but they know units. You don't get the units point unless you get an answer.
So
What
if
if the
we
answer
get
is
the
wrong?
wrong answer, we're
Okay,
taking-
no. If you at least have calculus work there. Okay, but you guys gotta read the problem.
Random
Yeah.
calculus.
Shh. It says, express your answer in inches per minute. Oh, this is feet per minute. So how do you
Times by
come?
12.
Let's do some dimensional analysis. You need feet and
12
inches.
inches
1 foot
per
is 12 inches, so you gotta times this by 12. And by the way, the answer is gonna be negative. But you gotta answer the question. The question is asking, how fast is the shadow's length decreasing? So, okay, let's call this K. I don't know what the number is. You guys are gonna crunch the numbers. Okay, so on the test, if I say, how fast is X changing, your answer would be -K times 12 inches per feet. Inches per minute, sorry. These cancel out, right? Everybody understand? But the question in the book is asking, how fast is the shadow's length decreasing? So what should the answer be? K inches per minute.
What's K?
The number that you crunched here.
No, I know.
Now I noticed the people that did come in for help, they did it on their calculator, but I'm sorry, you got no calculator on the test. You're gonna have to crunch these numbers. Okay, next one. Okay, if I were you, look, I can't tell anything from this. Okay, you want me to help you out on the test? Then you better know how to do 35, 34, 35, and 42. So do those. You guys better make a decision because we gotta learn today, you know?
Is there a practice test?
Yes! There are practice problems, but that's not gonna be collected for homework, that's just the practice. But you guys better learn how to do these before you do the ones on the website. So do you want me to do 34, 35, and 42?
Can we go?
Because the probability is quite high that all
I
three.
wanna go Halloween trick or treat.
Then we should have spent more time this past weekend working on this, so that I don't have homework for tomorrow night.
You're right.
What was the answer?
I got 15 highway.
Okay,
Is that the same thing?
did you guys read this problem? Did you guys read this problem? You know what's happening? There's a walker going that way. This is junk. This thing is not holding it. There's a walker walking that way, and there's a walker walking that way. This distance changes, that distance changes, that angle changes. Everything changes. First step, write an equation that relates this variable. This is like the same thing we had already.
Tan inverse.
Oh, why are you texting?
Sorry.
You think teachers cannot see?
How's the conference?
How do theta equal tan inverse
Yeah.
y over x. Look, that's like the third problem we did that. Second step, take the derivative. Theta dot is equal to 1 over 1 plus box squared times the derivative of box. I see a quotient, I'm going to use the quotient rule. Low d high minus high d low. All over denominator squared we go. And then all you have to do, because you're asked to find theta dot, all you gotta do is plug in the numbers. Can you plug in the numbers? Okay, well I will then. X, Y, X dot, and Y dot. Okay, I'm just gonna call on people and you guys better have the answer. You guys better have the book in front of you. Or you better look over somebody's shoulder. Wall, what am I gonna plug in for X?
That's always a wall.
No, because I'm starting there. No, no.
Not training the book.
Yeah, I know, no. If you don't have a book, you look over somebody's shoulder. Okay, we're wasting time. What do I plug in for X? 20. Okay. What do I plug in for Y? Olga, what do I plug in for Y? 10. Correct. What do I plug in for X dot? Who's next? Hui.
That's her.
Which one?
I'm going in order here. You know it's this Hui. Hard out when you're reading the problem for the first time now.
Yeah. Kind of hard.
1.
This is BC. BC stands for something.
2.
No, it's 1. What do I plug in for y dot of it?
2.
No.
Negative.
-2. How come negative? Because
going
if
down.
this is coming down,
Oh, yeah.
this distance is getting smaller. That's
You
going to
get
cost you
the
2 points. Can you plug in these numbers over here? Yes. What do you mean? No. What are the units going to be? Yoshida, what is this? Theta dot. What are the units?
Radian.
And you better not say degrees.
Oh yeah, radians per.
Radians per second.
Whoa, Ricky.
Oh.
So plug in these numbers, and the answer is just radians per second.
Can you?
Let's just get that.
Unless I say, write your answer in degrees
This one
per
says
second.
You gotta
What?
divide by.
Oh, this one says degrees.
Yeah. So then
Oh, so we gotta convert dimensional analysis.
Yeah.
Radians, degrees,
180.
pi radians is 180. So whatever answer you get, you gotta multiply it by 180.
That was not a long problem.
Sorry.
That was too loud.
No, for real, I'm gonna pity some of you on this test here.
I pity myself.
Okay, how many people, you know what, I need room to do 35. It's 35, I'll give you a hint, on my AB test, 35 is on every single test I've given in the last 20 years. Okay, how many people got 35? Very good, now the rest of you,
I'm reading the problem for the first time, Mr. Parker.
I know that, and you want me to write you a letter of recommendation.
Yeah.
Whoa!
No,
I might need
I
one
thought
because
Mr.
I have
Highlight
my
was
letter,
right.
but,
Oh yeah.
That's
Okay,
precisely
here's
the
all.
reason I didn't ask you.
For those of you who didn't read the problem, ship A is moving away from point O, so it's going that way. Ship B is moving away from point O that way, it's going that way. This angle, does that angle change or does it stay the same?
Same.
And what is that angle?
Up to
120 degrees. Now, this distance between the two ships is also changing. So this changes, that changes, that changes. You can use whatever letters you want. You can use X, Y, Z if you want. Now, look at this picture. What equation relates these variables?
Oh,
Now, if this was a right triangle, I could use Pythagorean Theorem.
Oh,
but
the
it's
law of
not
sines.
right-
No,
Law of cosine.
Lost.
So what is the law of cosine? C squared equals A squared plus B squared minus 2AB cosine of this angle that doesn't change. Now, cosine of 120 degrees is a number that we know. Who's next in line? Who? No, it's not one. Cosine of 120 degrees is a number that we know. No, it's negative half. So this equation reduces to c squared equals a squared plus b squared. Now half cancels the 2 plus ab. Because this angle stays the same. Now I remember on my AB test one year, I just wanted to see if they knew what they were doing, so I said, this angle is changing at a certain rate.
Oh, that's different.
So then you gotta just leave a variable there instead.
That's kind of mean.
But that would be a BC problem, wouldn't it?
No.
Okay, so does everybody understand how I got this equation? Now, if you don't know the law of cosines, kiss this problem goodbye. Now, here are the most common mistakes from
We
AB.
gotta still learn.
They put a sign there instead of cosine, even though it's called the law of cosines. I don't know why. They forget the 2, they forget that it's minus. That's the
Wait, why is it labeled? Shouldn't capital A be across lowercase?
No, I'm just labeling it with letters. Okay, you can use. Maybe you should go X, Y, and Z then. It doesn't matter what letters you put there, as long as you understand what's happening in the picture. Second step, take the derivative with respect to time. 2c c dot equal 2a a dot plus 2b b dot plus, and then that's a product. Use the product rule. A dot b plus a b dot. So all you have to do to compute C dot is plug in numbers for A, B, C, A dot, and B dot. Okay, I'm gonna go around the room asking, Owen, what do I plug in for A? Correct. Wait. What do I plug in for B? Choi. Huh?
Age
Yeah, that's what it meant.
morning.
5. Show
That's the
me, what do I
morning
plug in
bird.
for B?
After
3. Who's next? La, what do I plug in for C?
8.
Which is not given.
Oh, it's not good.
Oh,
So it's easy, Lau. Since it's not given, you figure it out. Here, look, the arrow is pointing right there. If I know A and B, how can I figure out C?
Which problem?
And remember from PCH, remember I told you, every time I give you a long cosines problem,
Oh, 7.
whoa, whoa.
whoa.
7. Okay, what do I plug in for A dot Mamachane?
Hey, you skipped a couple people. You skipped that.
Not just to keep you honest, because you guys are looking ahead already.
Shucks.
Mamachane, what do I plug in for A dot?
Wait, which problem?
Okay, to save time, I'm gonna put 14 here and 21 come out.
Yeah, it's 21.
Plug in the answer, and you're gonna get C dot is something, and what are the units? Knots. And you know a knot is already a unit of speed, right? Because some people they go knots per hour.
Oh, that's like hertz.
That's like actually an acceleration. It's just knot. Do you know what I mean? Someone going, isn't it? Kinda. Okay, we're in trouble. Okay, let's do 42. Oh, hey, 42!
Hey, that's the best number.
Okay, I'll tell you right here. This problem is on the test. It's on the test A, B, and BC. You better know how to handle similar triangles in this problem. Now, we already had it once on the homework. Here it is twice. If you do the practice test, it's on the 3rd time. It's on the test. Possibility 1. Except there's a little twist in this one.
Oh, it says 14 and 21 radians.
Okay, so we got that. Didn't we do this problem before? We did this problem before. But the only difference now it's dripping into a coffee pot over here. That's the only difference. So, this is the coffee in the filter right here. So as coffee is being poured in, the radius changes, the height changes. What is the radius of the filter?
10.
No, it's 3. This is 3 inches, and that's 6 inches. So, boom. How do you figure out the volume of the coffee in the pot? What's the formula for a cylinder?
1/3.
1/3 pi r squared h. But from experience, you know that you're going to use similar triangles to solve this problem. So looking at, do you see the similar triangles? Do you see the bear, the baby bear in the womb of the mama bear? Yes. So r over h is, didn't Mrs. Goto go over this problem?
Yeah.
So what's the problem? R over h, short leg over long leg, equals
1/2.
3 over 6, which is 1/2. So therefore, what do you want to do? You want to solve for r or solve for h? From experience.
H.
R. No, you want to solve for r. R equals 1/2 h. So if I take that and plug it in there, the volume is 1/3 pi times r squared, which is 1/4 h squared times 8. So that's pi over 12 h cubed. That's your equation. What's the second step?
Derivative.
Take the derivative with respect to time. So v dot is equal to, put the 3 in the front, pi over 4 h squared times the derivative of h, h dot. You know what a common mistake in AB is? They forget the h dot. They forget to multiply by the derivative of the
That's a
box.
fatal.
And therefore, how can you solve for h dot if there's no h dot there?
Guess
You cannot, they get stuck. Minus 12. Okay, so, see, part B, it's better to do part B first. How fast is the level in the cone falling at that moment? So we want to compute h dot, which means I need to plug in numbers for v dot and h. Okay, I'm going to start calling on people. What do I plug in for v dot?
10.
Huh?
10. Negative 10.
Yes. How come negative? Because the coffee is draining from here. It's getting smaller. So that negative is going to cost you 2 points if you don't do it. What do I plug in for h, Hui?
Oh, he skipped me. Oh, right.
Look at part A.
Oh,
5. Okay, so you plug in these numbers. Can you see that h dot is going to come out negative something? What are the units for this? What are the units for this one? Who?
In inches.
Inches per minute. Okay, but you gotta answer the question. The question is asking, how fast is the level in the cone falling? So what's the answer? The answer is just K inches per minute. Because they're asking how fast is it falling. On my test, however, I'm gonna ask you, how fast is it changing?
So then you
So
put
the answer would be
negative.
negative K inches per minute. You see the subtle difference between
Yes.
the two?
Yes.
Okay, good. Now let's do part A now. How fast is the level in the pot rising when the coffee in the cone is 5 inches deep? So here's the coffee in the pot here. This distance is changing, I'll call it H, or you can call it whatever letter you want. What is this?
3.
It stays constant, right? Because it's a cylinder, that's why, right? So what is the volume of the coffee in the pot?
1/3.
No, it's a cylinder. Pi times the radius squared
9.
times the height. Second step, take the derivative with respect to time. V dot equals 9 pi h dot. They're asking how fast this is changing. Maybe we shouldn't have used h because that's h, yeah? Is that
Yeah.
confusing?
Yes.
Okay, let's call that y then.
Big H.
Y dot. So we want to find y dot, that means I have to know what v dot is. Well, what is v dot? Wait, let me call on somebody. Tran, what is v dot? That's easy, you got the
wait.
easy one. You got the easy one, you don't need to look at the thing.
10, negative. And the 10.
No, it's positive 10. How come v dot for this one is negative 10, but v dot for this one is positive 10? Because this one's getting smaller, this one's getting bigger.
Oh, law of conservation of mass.
Now, you're not gonna have a calculator on the test, people. You gotta crunch these numbers without a calculator. Leave pi in your answer. Pi in your answer. Okay, look, we only got 10 minutes left. We gotta learn a whole lesson, people. So, if you guys still have questions, you guys gonna have to come in for help. But look, every single problem is the same. You write the equation, you take the derivative, you plug in the numbers. It's the same every problem. Write the equation, take the derivative, plug in numbers. Now, every once in a while, you have to use similar triangles. You're gonna use it on one of the 3 problems. Please use it on the right one. Otherwise, that's 2 minus 12. Yeah.
Are you still doing QQ4?
No,
We don't have time. That's linear. We did that. Linearization. Last chapter. That's like a review.
What chapter?
Derive it, plug it in.
Do you guys remember this? Linearization.
Yeah.
Is it
Never
an
heard the word in a
underestimate
while.
or an overestimate? Remember, you gotta look at the concavity. Does this sound familiar? If the graph is concave down, then it's an overestimate because the line is above the graph. Does that mean?
What did the
You guys are acting like AB. Take the test and purge. You know when you take the AP exam, it's on the whole course. You know?
That's what a month of review.
Okay, well, you guys gave me 10 minutes to do this. Well, if we don't finish, tough luck, c'est la vie. Read the book. Anyway, you guys need practice because when you go to college, your professor is probably not going to speak very good English. And so, what did he say? What is he talking about?
so it's
Yeah,
a
you know what
good
you're
thing
going to
I
do? You're going to
understand
read the
that
book.
English.
That's what's going to happen in college.
I understand that English.
Okay, let's go back to physics. Okay, time versus position. Yeah, now we are done, now we are officially done with differential
Oh,
calculus.
we're doing in
Calculus is broken up into 2 parts. You got differential calculus, the study of derivatives. And then the second half of calculus is called integral calculus, the study of integrals.
back at it.
Okay, now, in physics, what did we learn? If this is the graph, sorry, wrong. If this is the graph of velocity,
Oh, that's this
what
way.
does this area represent?
Distance.
The
Position.
distance
Displacement.
traveled or displacement, right? So let's just do a quick review of, well, you never took physics, so you don't know yet. Ooh. Okay, now this is the kind of graphs you get in us. Okay. Whoa, whoa. Okay. So let's say that this area is 4, this one is 3, this one is 2. This is the velocity. So what does this mean? The particle traveled from here to here, the particle traveled 4 units
To the
to the
right.
right.
To the right.
What does that mean? The particle then traveled 3 units to the left,
To the left.
and then that means the particle traveled 2 units to the right. So you gotta be able to answer 2 questions.
3.
What is the total distance traveled?
Add it up.
Well, if you went 4 to the right, 3 to the left, and 2 to the right, how far did you travel?
9.
9 units, whatever that is, right? What about displacement though?
Well, that's 3.
Positive.
What is the displacement of the particle from here to here? Well, if you traveled 4 units to the right, then you went 3 to the left, and then went 2 to the right, how far from the starting point are you?
3.
Plus 3.
Plus.
Yeah, 3. So you're 3 units to the right of where you started. So if the displacement is positive, you ended up 3 units to the right of where you started. If the displacement came out negative, then it's to the left of where you started. Does that sound familiar?
Yeah.
Okay, now the kinds of graphs you got in physics though, they weren't like this, right? They were like,
They were just boxes.
yeah, like this, blah, blah,
Trapezoid.
blah, blah. So like that's a trapezoid, that's a triangle, easy to compute.
Just
But
broke the
but
triangle
in-
into a rectangle.
Cannot be a rectangle. I guess it could. I guess it could be.
Yeah,
But-
not rectangles.
But in real life, is it gonna be like these nice uniform shapes?
Can.
No, so that's where calculus comes in.
It's
So,
possible.
I mean.
so Sir Isaac Newton knew that in order to compute displacement, you have to be able to figure out the area under the curve. Now, in tonight's homework, we're not gonna compute the exact area, we're only gonna estimate it.
Oh, the
Box method.
So
Serious.
one way to estimate it is to break it up into a finite number of rectangles.
It's over.
And we're not gonna do trapezoids yet, that's like the end of the chapter. So tonight's homework, we're just gonna make rectangles. But there's lots of different ways of making rectangles. You can use the right endpoint like this. Use the right endpoint to cap off the rectangle like this.
Oh, this.
You know what your book calls this if you use the right endpoint?
The right hand.
It calls it RAM. The right endpoint rectangle approximation.
Ram.
That's what your book calls it.
Ram.
Now-
Ram is an Indian name.
If another way is if you break it up into rectangles, you could use the left endpoint. So like here, cap off the rectangle using the left endpoint like that. So wunga, wunga.
Oh, that's a lot of air.
Yeah, the fewer rectangles you make, the bigger your error is going to be, right? So if you add up the area of these rectangles, we call this LRAM. Left
Alright.
endpoint rectangle approximation method. And then the other one you need to know is called
LRAM.
MRAM.
Middle.
Yeah, midpoint. So what if you have something like this, and let's say you just break it up into 4 rectangles. So here, you go halfway in between, compute that y coordinate, boom,
Midpoint.
makes a rectangle. So halfway in between, compute the y coordinate, that's the height of the rectangle in there. Find the midpoint, find the y coordinate there, boom. Find the midpoint, make a rectangle, boom.
Oh, that's
Add
a
up
lot
those
of
4
air.
rectangles using the midpoint. So let's do a specific, oh gosh, you guys didn't give me hardly any time. Okay, let's do this.
We'll just go quick time.
No. Okay, 0 to 2. We're gonna break it up. Okay, so this is how it's gonna be mentioned in your book. Estimate the area using RAM4.
Ram.
So R means you're gonna use the right endpoint. This 4 means you're gonna split it up into 4 rectangles of equal base. Okay? So here we go. Look. So if this is 2, wouldn't that be 1? And that's a half and 3 halves? Why don't we compute the coordinates of each of these points already? Save time. So this is 0, comma 1. This is 1/2, comma
1/4.
5/4. Just plug it into here, people.